In my last couple of videos, we've been exploring linear inequalities, how to check to see if things are solutions of them or how to graph them. In this video, we're going to talk about, what if I already have the graph of the solutions of this linear inequality? So we have this boundary line right here that's a dashed line, and we're shading underneath this here. Could we come up with the equation of this? And this is something that we've already kind of practiced before, how to write the equation of a line. Recall that when you write the equation of a line, we need two things. We need a point, some point on the line, so some point xy, and it doesn't matter which one, and slope. Okay, so we need these things. So that being mentioned here, let's go ahead and take a look at this line and see if we can come up with its equation using what we know about lines in linear inequalities. So when it comes to finding the equation of this, do we have a point or do we have a slope? I notice that I don't have any specific points told to me, but I suppose that I could point some out to myself. So for example, I'd say the point -4, 0 is on this graph. Looks like also maybe this point here is the point 1, 2 is also on this graph. What we'd like to do is actually come up with the equation of this line, so we're going to need the slope between these 2 points. So what if we were to count rise over run? I suppose we could do that, and since we have the picture, this is not a hard thing to do here, but it looks like we've risen 2 and we go 1, 2, 3, 4, 5 to the right. So in this instance, we could say the slope is rise of 2, run of 5. Now I do want to mention something about this here. Let's say I didn't have this image, but somebody did actually tell me that these 2 points were on the graph, -4, 0 and 1, 2. I do want to point this out that we could have just used our definition of slope, which is change in y over change in x, to determine the numerical value of this right here. We would say that our y2 minus y1, we would have had 2 minus 0 on top, and then we say x2 minus x1, looks like we have 1 minus a -4, so we end up with this. We say 2 over 1 minus a -4, which is adding a positive, we get 2/5. So we still get 2/5. Okay. So now we need to write the equation of this. Now that we have a point, actually we have 2 points, we can take our pick. I'm going to use, say, this one right here. So we have the point 1, 2. We have some x and some y paired that we know is a solution to this, and we have a slope of 2/5. If we want to write the equation of this, then all we need to do is substitute it into this right here. So now one thing I want to mention before we go ahead and do this is really this. Notice that, of course, we're not graphing just an equation, which would be just the line through these 2 points, but we're graphing this dotted line through this, or this dashed line through this, and all of the points down here. So when we're finished here, we're going to actually have to judge what should we be putting here instead of an equal sign. Should it be, say, less than or greater than? You notice I didn't say less than or equal to or greater than or equal to because this is a dashed line, but less than or greater than. But we'll settle that issue when we get to it. So for now, let's kind of work with what we have here. We say we have some y, we have an m with slope, we have an x, and we have no b. So we're going to go plug in what we know about this. We say, well, a solution pair, we say, would be 2 for y and 1 for x. Of course, we have 2/5 for our slope. So now let's go ahead and simplify this and try to find out what we have for b here. But we have 2 on the left is equal to 2/5 times 1, which is 2/5, plus b. So now we need to subtract 2/5 from both sides, which means we are going to need a common denominator here, but we have b on the right. Let me switch colors here. B on the right, and on the left we have 2 minus 2/5, okay? Or 2 wholes minus 2/5. Or if we were to take both the top and bottom of this times 5, okay? We would instead have this 10/5 minus 2/5, which is actually 8/5. So we have now solved for b. That is, we have m is 2/5 and b is 8/5. What we can do now is write the equation of this line. We say y equals, and well, let me take that out of there. Y something mx plus b, okay, where we know b now. So we're going to go ahead and put in the slope. We say 2/5 x. Then we also have over here 8/5, okay. So now the question really becomes this. Should I put a greater than or a less than? And that's really the question. So we say, well, in previous videos what we did was we tested a point. And so what I'm going to do is I'm going to carry this over here closer to our graph. We say y something 2/5 x plus 8/5 but the question is, what should we put in here? Just like we tested a point before, we can do this again, and we say, well, 0, 0 is actually, we know that 0, 0 is a solution because it's in this shaded region. So if we were to plug in 0, 0 for x and y respectively, we should be getting a true statement. So if we were to plug this in, again, still, I don't know what this is, but we're going to determine this. If we were to plug in 0 for y, and we say plug in 0 for x, so we get a 0 here, plus 8/5. What I know about this essentially is, well, 0, 0 should work, and by the way, this term drops out because anything times 0 is 0. So we get this 0 blank 8/5, and so since 0, 0 makes it true, we need to make this statement true. And so the question is, should this be less than or greater than? And in this case, we get 0 is less than 8/5, which would mean this is less than, which would mean this is less than. So this is just like writing the equation of a line. It's just that when we're done, we need to assess, should I put a less than or greater than, or less than or equal to, or greater than or equal to, based upon some point that we know would have been true in the first place. We would plug that in and then cause the end statement, like this one here, to be true. Okay, so before I kind of abandon this video really quickly, I mean, that's all I needed to say about writing the equations of this. One thing I want to say about this equation is it's in slope-intercept form. I actually maybe would want to put this in standard form, and you notice that we have fractions everywhere. Okay, so when you're dealing with something like this and somebody says, well, you know, maybe you write this in standard form, which would mean we want to get all the variables on the left and all the constants on the right. Before I even do that, what I'm interested in doing is this: why don't we take both sides of this equation times the least common denominator, which would mean I get 5y on the left, and on the right we would distribute this 5. You notice that the 5's would cancel out in either case, and I'd get left with this 2x plus, now this 5 and this 5 would cancel, I get 8. Okay, so if I wanted to go to standard form now, we could just subtract 2x's from both sides, and we get this: negative 2x plus 5y is less than 8. And this would say the same thing as our linear inequality here. But know how to write the equations, or sorry, inequalities for these the same way you do equations, and also know how to switch from standard to slope-intercept and slope-intercept back to standard. Cheers.